right, 6.3. The 6 trig functions. So a lot of this is geometry. You guys went over this last year. We're using SOHCAHTOA for this one. So when you're looking at it, you have SOHCAHTOA. We should know what that means, but if not, I'm going to just briefly go over it. So if you're looking at this right here, SOHCAHTOA stands for sine opposite over hypotenuse. Cosine, which is adjacent over hypotenuse, and then TOA stands for tan opposite adjacent. So if you're looking at it, you have SOHCAHTOA. So it definitely helps. And then we know the inverses, cosecant, secant, cotan. All you're doing is flipping them. Okay, so sine, cosine, tangent should be pretty easy. Again, you guys covered this in geometry. Okay, if you have a missing side, all you're using is the Pythagorean theorem. And in that case, we should know that's a squared plus b squared equals c squared, where c must be your hypotenuse. You have to use your hypotenuse as c. Now, how do I know which side's opposite? How do I know which side's adjacent? And where is my hypotenuse? We should know that hypotenuse is always opposite your right angle. Okay, so again, for these, we're dealing with right triangles. When you're with SOHCAHTOA, it's always right triangles only. And your hypotenuse is always opposite your right angle. Now looking at this, if we're looking at angle theta, which is this angle right here, you have to think, now how can I determine if it's opposite or adjacent? Adjacent means next to. So it's the side that's next to your angle. Opposite of your angle is the side that's opposite. And then, like I said, hypotenuse is opposite that 90 degree. Now, if they were asking for theta on this side, if they were asking me for theta on that blue angle right there, this side would now become my adjacent. Oh, a little small. Adjacent over there, and this side would now become my opposite because it's opposite that angle. So you have to be able to determine what is where. Keep in mind your hypotenuse is still staying your hypotenuse because that's opposite your 90 degree angle. So that one is not moving anywhere. Okay, that one's going to stay there for both. Okay, but that's just something that we should know. Again, you should have learned it last year in geometry, but if you don't, this is more of a refresher slide for you. All right, so let's go ahead and do an example. This one asks, find the 6 trig values. So if I'm looking at this, just going ahead and looking at what they gave me. Okay, I'm finding all 6 trig values. So I have to find sine, cosine, tan, cosecant, secant, and cotangent. According to this angle, okay, I have opposite, I have adjacent, and I have my hypotenuse. Which one would be opposite of angle theta? It's the side that's opposite, so looking at it, it would be 12. Okay, just labeling everything. Adjacent is the side that's next to it, so it's my 5. And then my hypotenuse, I have to go ahead and solve for. So in order for me to solve for my hypotenuse, I have to use that a squared plus b squared equals c squared, where c is my hypotenuse. So I'm representing it as x. I'm going to have 12 squared plus 5 squared equals, I don't know, squared. I'm going to get 144 plus 25 equals x squared. And then adding those, I'm going to get 169 equals x squared. Getting rid of that squared by square rooting. And this one we should know is going to be 13. So my hypotenuse equals 13. Now I'm able to find all 6 trig values. I have my opposite, I have my adjacent, and I have my hypotenuse. So going ahead and writing what I have to find. Okay, using what I have to find my sine theta, my cosine theta, my tangent theta, and then I have to find my cosecant theta, my secant theta, and my cotan theta, okay? Like I said, done some of these in geometry, so I know ca, toa. That's going to help me with the first three, sine, cosine, and tan. Then I have to flip for cosecant, secant, and cotangent. So going ahead and writing these. Sine is opposite over hypotenuse. So my opposite side is 12. My hypotenuse is 13. I can't simplify that, so that would be my answer for sine. Cosine is adjacent over hypotenuse. Can't simplify that, so I'm good. And then tangent is opposite over adjacent, which is 5, and again, cannot simplify 12 over 5. All right, looking at cosecant. Okay, all we have to do for these is flip it. I'm going to get 13 over 12. For secant, I'm going to get 13 over 5. And then for cotan, I'm going to get 5 over 12, and that's it. Don't have to simplify anything. No radicals in my denominator, and I'm done. All right, now special right triangles. Star it, highlight it, pin it. This is super important for you to know. You have to know special right triangles in order to solve for all the rest of the questions on the slides. If you don't know the rules for special right triangles, you have to memorize it. They are not given to you. You have to know it. So there are two special right triangles. There is a 45, 45, 90, and a 30, 60, 90 triangle. So these are my special right triangles, and you have to know the rules for both. Just quickly going over this. In geometry, we use A, but it's the same thing. So when you have a special right triangle, 45, 45, 90, this side is A, this side is also A because this is an isosceles triangle, and both of these are congruent. Let me just get rid of this. 1 mark, it should be 1 mark only. Okay, and then your hypotenuse is A times the square root of 2. Now, what is the A for? A is basically saying if they gave me a value, that's where I'm putting that value. So giving you an example, if I gave you a 45, 45, 90 triangle, here's my 45, 45, 90 triangle. If they said that this side was 5, let's say the measurement was 5, that means this side is also 5, and my hypotenuse would be 5 times the square root of 2, because all I'm doing is replacing 5 or A with 5. Okay, so you can solve for a side if it's missing. You could actually solve for 2 sides if you have only one given, no matter the special triangle. So this is 45, 45, 90. Let's go ahead and look at my 30, 60, 90 triangle. For this one, opposite of 30. Now you have to think of the opposites. Opposite of 30 is 1, or you can say A. I'm going to be using A for these. Opposite of 60 is what I like to use as A square root 3. And then opposite of 90 is 2A. Okay, keep in mind, if you're only given one, you can solve for the other 2. So I'm going to give you an example. Here's an example of a 30, 60, 90 triangle. Okay, I have my 30, I have my 60, and I have my 90. If they said my hypotenuse was 24, find the other missing sides, okay? I know that this side is 2A. How would I solve for A by itself? I'm going to divide both sides by 2, and I'm going to get A is going to equal 12. So that means A is over here. This is 12. And then I have A times the square root of 3. This is going to be 12 times the square root of 3. So you can always find something that's missing because you have to memorize special right triangles. So again, you have a 30, 60, 90 and a 45, 45, 90 triangles that you guys have to know. All right, so let's go ahead and solve these examples. It says find the 6 trig values. So for this type of question, okay, I'm just going to go ahead and they're giving me the angle. They're saying if I have sine angle 30, what would my trig value be? So I'm going to go ahead and draw my triangle. Now, if they're telling me my angle is 30 degrees, what kind of special right triangle would this be? Would it be a 30, 60, 90 or 45, 45, 90? This is going to be a 30, 60, 90. Again, how do I know that? Because they're saying sine angle 30. Okay, so I have to have a 30, 60, 90 triangle. So if I'm looking at angle 30, which in this case is right here, I have to determine what I have. I have to also know my rules. Opposite of 30 is A. Opposite of 60 is A square root 3. And opposite 90 is 2A. Okay, I'm also going to go ahead and label this. Opposite of 30, we said is A, so this is opposite. This is adjacent because it's next to my angle, and this is my hypotenuse. All right, next thing we're going to do is we have to know SOHCAHTOA. Okay, so I'm just going to go ahead and write it at the side. Sine is opposite over hypotenuse, that's my SO. My ka is cosine, which is adjacent over hypotenuse. And then my tan, my TOA, is opposite over adjacent. So all I'm going to do is write those values, and if I have to solve for something or simplify or rationalize it, I have to. Okay, so sine 30, again, we're using angle 30. Opposite 30 is A. Okay, so I'm going to go ahead and use A for this. Let me grab a different color. I'll use orange. I'm going to have A over my hypotenuse is 2A. Okay, I could simplify this. My A's can be simplified to 1 and 1. I'm going to get 1 over 2. Can't do anything else. I'm going to leave it like that. Cosine 30. Cosine is adjacent, which is A times the square root of 3 over my hypotenuse, which is 2A. My A's can be simplified, and I'm going to get the square root of 3 over 2. Looking at my tangent, that's opposite over adjacent, which is A times the square root of 3. A's are going to simplify, and I'm going to get 1 over the square root of 3. I cannot have a square root in my denominator, so I'm going to go ahead and rationalize it. That means I'm multiplying top and bottom by the square root of 3. And I'm going to end up with square root of 3 over 3. Okay, and this would be my answer for tan 30. Now, cosine 30. Keep in mind, I am not taking the answers I got. I'm taking what I started with. So this one's going to be 2A over A. My A's are going to simplify, and I'm going to 2 as a whole. Secant 30, I'm going to have 2A over A times the square root of 30, or not 33. My A's are going to simplify. 2 over the square root of 3. I cannot have a square root in my denominator, so I'm rationalizing it. And I'm going to end up with 2 square root 3 over 3. And then my last one, cotan 30, I'm going to end up with A times the square root of 3 over A. My A's are going to simplify, and I'm going to get square root of 3 left. So these would be my trig values for all 6 of them. Okay, so please make sure you remember those rules. Have to know those rules for special right triangles. All right, looking at the next example, sine 60. Okay, because I have 60, I know one of my angles are going to be 60 degrees. So I have 90, I have 60. That means I'm going to have a 30, 60, 90 triangle. Now looking at this one, still have to know those rules. Opposite of 30 is A. Opposite of 60 is A times the square root of 3. And opposite my 90-degree angle is 2A. So again, for this one, we are going to go ahead and we are using angle 60. So this is going to be opposite. This is adjacent. And this is my hypotenuse. Again, if you know SOHCAHTOA, you should be able to find the first three. So I have SOHCAHTOA. And using that to help me find the rest. So if I'm looking at it, sine 60, I'm going to have opposite over hypotenuse. So that's going to be A times the square root of 3 over 2A. My A's are going to simplify. I'm going to end up with the square root of 3 over 2. Cosine 60, I'm going to have A over 2A. My A's simplify. I'm going to get 1 over 2. Tan 60, I'm going to have A square root 3 over A. A simplifies. I'm going to get the square root of 3. Okay, so pretty easy for those three. Now cosecant, I'm going to take what I originally had and flip it to A over A times the square root of 3. I have to rationalize this. That means I'm multiplying top and bottom by the square root of 3. And I'm going to end up with 2 times the square root of 3 over 3. Going to secant 60, I'm going to get 2A over A. My A's are going to simplify, and I'm going to get 2 as a whole. And then cotangent 60, I'm going to have A over A times the square root of 3. Rationalize it. And I'm going to end up with the square root of 3 over 3. Okay, so again, not too difficult, but you have to remember your rules for special right triangles. You can memorize these, but if you don't want to memorize them, again, you still have to know your rules. All right, looking at another example, now I have sine 45. I'm dealing with 45-degree angles. So this is going to give me a 45, 45, 90 triangle. Now, which 45 angle are you using? It does not matter. Okay, why? Because I'm going to have A, and A times the square root of 2. So doesn't matter which 45 you use. So let's just go ahead and say we're going to use the top one. Okay, here's my 45. My opposite and my adjacent are going to be the same. And this is my hypotenuse. So nothing too hard here. Again, sine, cosine, and tan, we know SOHCAHTOA. And that's going to help me set up my trig values. So if I'm looking at it, sine is going to be opposite over hypotenuse. In this case, I'm going to have A over A times the square root of 2. My A's are going to simplify. I can't have that square root in the denominator, so I'm going to go ahead and rationalize it, which I'm going to end up with the square root of 2 over 2. Looking at the next one, cosine 45, keep in mind it's adjacent over hypotenuse. Opposite and adjacent are both the same. So I'm still going to have A over A times the square root of 2. And I know I'm going to get the square root of 2 over 2. So pretty easy for that one. Looking at tan 45, tan is opposite over adjacent. Simplifying these two, I'm going to end up with 1. So pretty easy for that one. Now looking at cosecant, I'm flipping what I had for sine, which is A times the square root of 2 over A. My A's are going to simplify, and I'm just going to have the square root of 2. Okay, secant, same thing. A times the square root of 2 over A. My A's are going to simplify, and I'm going to end up with the square root of 2. And then the last one, for this one, I'm going to have adjacent over opposite, which they're both A, and I'm going to end up with one whole. Okay, that one is pretty easy. All right, now reference angles. Okay, the acute angle between the terminal side of an angle in standard position and the x-axis. So what does this mean? We did a previous lesson where we made a right triangle and we could find information from that triangle. But if I'm looking at these quadrants or these angles on the quadrants, I can't make a right triangle from this angle. Okay, I can't find my trig functions from this angle because I can't make a right triangle from an obtuse angle. So if I'm looking at it, what you have to do is you have to use the reference angle. This angle right here is called my reference angle. Why am I using a reference angle? Because I can make a right triangle using that reference angle. Okay, so here's my right triangle. This right here would be that reference angle. Okay, now how would I get the angle? How am I going to solve for the angle? What do I know the measure of the angle is? In degrees, you have to do 180 minus whatever angle you get, or whatever angle is given. So this angle right here, I'm plugging it into 180 minus whatever that angle is. Why? Because if this line, straight line, is 180, and I'm taking 180, subtracting what they gave me, that would give me whatever's left over, which would be my reference angle. Same thing with the second one. Quadrant 3. This is my reference angle because, again, I cannot make a right triangle from what they gave me. So I'm going to go ahead and make that right triangle using my reference angle. And for this one, it's going to be whatever angle they gave you minus 180. Because, again, this is 180, and that's whatever that leftover is as your reference angle. And looking at the next one, this is quadrant 4. This would be my reference angle. Again, I cannot make a right triangle from this angle right here. So in this case, an entire circle is 360. So I'm going to do 360 minus whatever they gave me right here. Okay. Keep in mind, if you're looking at this, there is no quadrant 1. Just showing you, if I were to draw quadrant 1, and this was my angle, I can make a right triangle from anything that's in quadrant 1. Okay, so if I have something in quadrant 1, I can make a right triangle from that angle. So just be aware of that. Okay. So just to recap, if you're trying to find your trig functions, okay, for any angle, you have to find your reference angle and use the rules of special right triangles to find the values. So please make sure you guys are finding that reference angle. And in the examples, you guys will see it. I'm only going to do the first 2 for now. And then we'll do the rest later. So looking at it, it says find the indicated value. Write it a little small. I'm going to first go through all the steps what you have to do. So try and follow along. It may look like a lot, but once I do the second example, I'm going to show you guys you don't have to do it so spread out and separate. So first thing you have to find is you have to determine what quadrant are you in. Okay. First, determine what quadrant are you in. So I'm just going to go ahead and draw a rough sketch right here. I have 0, I have 90 degrees, 180, and 270. Where would 225 degrees be? In which quadrant? 225 is in between which two numbers? 180 and 270. So just a quick rough sketch, it's going to be right here. Okay, this is where it's going to be. So I know it's in quadrant 3. Okay, it's in quadrant 3. So just remember that. Now I have to go ahead and find my reference angle. Okay, reference angle. And how am I going to do it? Because it's in quadrant 3, I have to find what this angle is right here. So I'm going to go ahead and I'm going to do my 225 minus 180 because I want to know how much is left over from 180. And that's going to be 45 degrees. Okay. So my reference angle is 45 degrees. Now that's telling me what kind of triangle I'm going to use. Again, I'm going to use a right triangle. But that's telling me which right triangle. So in this case, I'm going to go ahead and draw that right triangle. And I know it's a 45, 45, 90. Because this angle right here is 45 degrees. So if you're looking at it, I'm kind of drawing it what I have right here. If I were to make this a little dotted line, this is kind of what my right triangle would look like. And now I know it's 45, 45, 90. I'm going to go ahead and label it. I have A, I have A, I have A times the square root of 2. Okay, now I'm going to go ahead and use my SOHCAHTOA. SOHCAHTOA. But keep in mind, I'm only looking for sine. Okay, so I have to know what sine is. I'm looking for sine 225. And sine, I know, is going to be opposite over hypotenuse. So according to this angle, which side is opposite? This is my A. Oof. And this is my hypotenuse. So I'm going to have A over A times the square root of 2, which in this case my A's simplify, and I have to rationalize it. So I'm going to get sine 225 degrees is square root of 2 over 2, but I'm not done. The last step is what we covered last class. My last step is, now I have to determine the sign. Is it positive or negative? So this is my last step where I have to use the all students take calculus. Because I'm in quadrant 3, only tan and cotan can be positive. So my answer would be negative. Okay, so for sine 225 degrees, my answer is going to be negative square root 2 over 2. So it's just quite a lot of steps that you have to go over and think about, but not too hard where you guys can do it. We're just adding everything together. All right, I'm going to go ahead and do the next one. I'm going to write it a little different just so you can see it doesn't have to use that much work. I just did that to show you guys every single step separately. So going ahead and working out this one, I am going to go ahead and just make my, just draw a coordinate. Just super easy, drawing a coordinate right here. And I'm just going to kind of do all my work on here. So instead of drawing everything separately, I'm going to use it here. So I know this is 0, 90, 180. These are positive, and this is 270. Where would 150 fall? I know it's going to be in between. Good, it's in quadrant 2. It's in between that 90 and 180. Okay, so this is where that 150 is. But I cannot make a right triangle from that. So I have to find my reference angle. Okay, I have to go ahead and find this blue angle right here. How would I find my reference angle? In this case, I'm going to do 180 minus 150 to get that left over. And if you subtract correctly, you're going to get 30 degrees. So looking at it, this is 30 degrees. And I'm just going to go ahead and draw that right triangle. So I have a 30, 60, 90 triangle. Now I have to know the rules for the right triangle. I'm going to have A Opposite of 30 is a. Opposite of 60 is a times the square root of 3. And opposite of 90 is 2a. Okay, have to know that rule. Now I have to go ahead and use my SOHCAHTOA. Remember, they're asking for cosine 150 degrees. And cosine, using SOHCAHTOA, is adjacent over hypotenuse. So adjacent means next to. This is my adjacent side according to that 30 degrees. This is my hypotenuse. It's opposite of 90. So I'm going to have a times the square root of 3 over 2a. Those a's simplify. And last thing I have to determine is it positive or negative? I have all students take calculus. Because it's in quadrant 2, quadrant 2 tells me only sine and cosecant can be positive. So that means my answer will be negative. So if I'm looking at it, what would my answer be? My answer for this would be cosine 150 is negative square root of 3 over 2. And that's what my answer would be. And I'm done. Okay, so it doesn't have to be that long. You just have to remember the steps on how to do them.